Hey again, it's Mr. Blum. And last time we looked at naming basic ionic compounds. And so sometimes we call them binary ionic compounds, just have two things in there. This one's going to be the same thing, but now we're going to be talking about multivalent elements. Now, there are some elements on the periodic table that make more than one type of ion, and these are called multivalent elements. So, if an element can make more than one type of ion, it is considered multivalent, and it gets a special type of naming. So the first thing, and the most important thing, is that we must identify what is a multivalent element. So an example of a multivalent element, this one right here is, okay, because it makes two different ions. This one right here is as well, makes two different ions. This one makes three, so lots. Here's two, 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 two. Okay, so I've highlighted all the multivalent elements. These ones are not multivalent, the ones that I'm highlighting right now. Okay, so all these multivalent elements are metals. And yeah, anyways, so they get a special different type of naming. So let's go over it. So the first one is how to name a multivalent element. So the first thing is identify the charge. And that should be easy because when you're given the formula, the charge is written for you in a Roman numeral. So here are some Roman numerals right here. And the I means 1, 2 I's mean 2, 3 I's 3, IV means 4, V means 5, VI means 6, and 7, okay? We shouldn't be going too much higher above 7, but anyways. So we're going to go through these different steps, and we have a couple of examples right here. We have chromium, and then III oxide, and III is 3, so we call this chromium 3 oxide. And so we're going to name this thing, write the formula of this thing using these three steps right here. So first off, identify the charge. Well, kind of step 1 and 2 are the exact same thing. The charge of the multivalent is written in Roman numerals right here. So if we have chromium right here and we don't know if it's chromium 2 or 3, well, it tells us what chromium it is. It says it's chromium 3. So I'm going to write down chromium 3. So Cr3+. I know it's chromium 3 because it tells me. Then I write down oxygen, and I write down the charge of oxygen as well, which happens to be 2-. Okay, I'm going to use the swap and drop method. So we swap and drop, so just the numbers, not the charges. And so this becomes Cr2O3, and that's our answer. So even though it's called chromium 3 oxide, it actually says Cr2O3, okay? Here's the next one right here. We have lead 2 oxide. So if we're wondering if it's 2 or if it's 4, well, it tells us. It says this is the number 2. So I'm going to write that one right down here. Pb2+, O2-, because we're still using oxygen. And we could use the swap and drop and it become Pb2O2. And if we do the swap and drop here, we get Pb2O2, common denominator thing. So we can take that out and it just becomes PbO. Just like that. Okay. Now, how to go the other way? We are given the formula this time, and we have to come up with the name. So first step is identify the metal's name. Check to see if it's multivalent, okay? This step is so important, people forget to do it. So we're going to identify the metal's name for this very first one right here, and we find that it's copper, right there. Check to see if it's multivalent. It is. It produces 2 different ions, so we have done steps 1 and 2. Determine the charge of the metal. Now this one's hard, okay? Now this one I like to use the old reverse swap and drop. So what I usually do is I write Cu like this above it, okay? And I write N above here. Now, we don't know the charge of Cu. It's either going to be 2 plus or 1 plus. We do know the charge of nitrogen though. It's 3 minus. So I'm going to write that up there. Okay. Now, since we're doing the reverse swap and drop, we're going to go up. So it's going to go 3 and then right there. It's going to go up like that. And see how this 3 right here goes up to this 3 right here. So there is no change. That's good. Now this one can be either a 2 plus or a 1 plus. And so this number right here, if we don't see anything, technically it's the number 1. So it goes up. And so since there was no change with the copper reverse swapping and dropping, there's going to be no change with the nitrogen when we reverse swap and drop. So I'm going to circle this one. So it is going to be the 1. It's going to be copper 1. So what I'm going to write down over here is I'm going to write copper. Since I circled the 1 over here, we're going to write in a Roman numeral the charge of the ion. So it's going to be copper 1. Okay. And I should be writing in brackets. Sometimes I forget to do that. Copper 1, and then I write nitrogen or nitride. Okay, and that would be our answer right there. So we have another one right here, PTS2. We look up PT, so we find PT here, and we find it's platinum. And do the and is it multivalent? The answer is yes. So we've done steps 1 and 2. And so we're going to write my PT up here, PT, and it's 4 plus or 2 plus, 4 plus or 2 plus. S is 2 minus, like that. Okay, now we're going to do the reverse swap and drop. Now this one's going to be a little tricky. So we have the number, we go from here, and now this starts as a 1 and it goes and becomes a 2. So along this way, it had to get multiplied by 2. Because it starts off as a 1 right here, because, you know, if it's nothing there, then that means it's a 1. So it started off as a 1 right there. It goes up, it gets multiplied by 2, and that's how it ends up as a 2 up here. So in other words, for this one, it's going to start off as a 2. It also must get multiplied by a 2, and so therefore it becomes a 4 right there, because 2 times 2, and that's going to be a 4. Since I circled the 4 ion right there, this one is going to be called platinum 4 sulfide. And that's how we name that one. So here we have a couple of examples. We have the periodic table down here, and you can try putting it on pause right now and answering these ones right here, and I'm going to come up with the answers in case you didn't see it. So anyways, so here we have FeO. Here's Fe on the periodic table right there. Here's O on the periodic table right there. So again, I'm going to write FeO reverse swap and drop. So I have Fe. If I look at Fe, it has a 3 plus ion, a 2 plus ion. O has a 2 minus ion. So since this is a 1 technically right there, when we reverse swap and drop, it has to get multiplied by 2. And this is also a 1 right here. When we reverse swap and drop, it also gets multiplied by 2. And so I'm going to circle the ion that we used. So I circle that ion. And since I circled the 2, it's going to be iron to oxide. So that's the answer to this one right here. Okay. Now, I'm just going to, rather than doing the reverse swap and drop, I'm going to write up the answers for these ones right here. So for this one, it's going to be, this one is going to be manganese 3 oxide. And for this one right here, this one says nickel 2 chloride. So this is back to our original way. This is nickel 2, so I find nickel, which is right there. It tells me the ion. It says 2 plus because it says it 2 right there. Chlorine is 1 minus. So when I swap and drop, it becomes NiCl2. Okay. And for this one right here, lead 4 oxide. This one's a little bit tricky. Lead, which is Pb. It says 4 there, so I'm going to write 4 plus. And oxygen, which is 2 minus. If you can't find lead, it's right here on the periodic table. Oxygen is still right there. And I'm going to swap and drop for these ones. And so since I swap and dropped, it comes Pb2O4. Now, this can have a common factor taken out of it, so divide both by 2. So it would then become Pb1, we don't write anything for 1, O, and then 4 divided by 2 is 2. So the answer would be PbO2. And that would be the formula for lead 4 oxide.